All right, so we looked at linear equation with a nonlinear equation. So now what we're going to look at is two nonlinear equations. And so it's going to be looking at systems with a circle and an ellipse kind of like, because those will both be nonlinear equations, or you can use other functions. So, it doesn't just have to be a circle and ellipse, it could be other kinds of functions. And what we're going to do is use elimination or substitution method, and there's going to be 5 possible answers this time. You're going to have no solution, one solution, two solutions, three solutions, or four solutions. And these are kind of represented below here. No solutions, you have one inside the other. So you could have the oval outside the circle as well. It doesn't have to always be inside. One solution, they're just touching, kind of like tangent. So, that's how that one's going to work. Two solutions, the the ellipse kind of cuts the circle on one side and you get 1, 2. Then you can cut it on one side twice and then touch the other side. And so that would give us 3, or it can cut through both sides and have all 4 solutions. So that's how it'll look. And if you ever want to kind of, after you get your answers, you can always plot this in Desmos and see, hey, does this look like it really should? Should I get, 3 solutions or should I get 4 solutions? And it'll kind of help you. Now, you won't be able to directly get and click on a button unless it's really nice numbers. Usually it's going to be like the square root of 13, which is not going to be a nice number on the graph in Desmos, so you won't be able to figure out what the numbers are directly. And so you'll actually will have to do the work to get to the solutions, but then you can check to kind of see, hey, what does that look like even maybe? So, all right, so let's do some examples here. And again, we're going to do elimination or substitution. It doesn't matter which we do. And this one, it kind of lends itself either way. I mean, I could see if I take the first equation minus the second equation, well, that's going to eliminate the y squareds. Or what I could do is I could say, hey, well, maybe let's solve for y squared, and I could substitute it in up here. Or I could even solve for x squared and plug it in up here. So, there's at least 3 obvious ways we could start this actual system of equations, and it all depends on your own personal taste on what you want to do. So let's be strange. Let's solve for the y squared this time. So y squared is equal to a minus x squared and then plus 10. So basically I'm just taking my x squared over here by subtracting it. And so now this is what y squared is equal to, and I'm going to plug that in to here. So that gives me 4x squared, and then just this directly, minus x squared plus 10 is equal to 13. All right. Now, when we have the quadratics in our final thing, what we're going to do is we're going to get the squared term on one side and everything else on the other. So I'm going to go ahead and subtract 10, because what we're going to end up having to do is take square roots on both sides. And so when we do that, 4 minus 1, so that's going to give me a 3x squared. And then, or I already, did I change? Okay, it is x squared. I'm like, whoa, did I already change values? I might have, but I don't remember. And then 13 minus 10 is equal to 3. And so I'll divide by 3. And so x squared is equal to 1. Okay. Well, I need x because I need the xy ordered pair. That's what I'm looking for. And so that means I have to take the square root of this side. And when I take a square root of a number, I have to take plus or minus that square root. And so x is going to be equal to 1, or x is equal to a negative 1. Now I've got those two. I can plug those back into any equation and solve for y. But since this one is sort of solved for y already, I'm going to plug it into that one. And so then I get y squared equals minus, and then that's going to be 1 squared, and then plus 10. And so then I get y squared equals, and then a minus 1 basically, plus 10. 10 minus 1 is equal to 9. And so I get y squared is equal to 9. So that gives me square root of that plus or minus the square root of that. So y equals plus or minus 3. Okay. Well, what about if I plug in a negative 1? Well, guess what? If I plug in a negative 1, that squares, it becomes positive. Then it has the opposite of that. Then I get the negative 1 plus 10. And so no matter which one I do, plus 1 or minus 1, I get the same answer here. Okay. So what does that mean? That means I get two solutions for both, because let's go ahead and do it. Just show we have two things here. So y squared equals a negative 1 squared plus 10. That equals a negative 1 plus 10, and that equals 9. And that's still y squared. So take the square root of both sides. Y equals plus or minus 3. So when we plug in 1, we can get two solutions. We plug in negative 1, we get two solutions. So if you think about that, that's going to give us 4 total solutions. And our solutions are going to be 1, 3, 1, minus 3, minus 1, 3, and minus 1, minus 3. So those are the 4 possible solutions. You would get 2 from this one, and we get 2 from this one, okay? And again, showing the check, you just plug all those in and make sure they all work. And so you just plug in, if we had 1 here, that's going to give us a 4, a 3 here, that's going to give us a 9. 9 plus 4 is 13, so it checks. 1 here is 1, 3 here is 9, 1 plus 9 is 10, and so that works. And if you think about it, it doesn't matter if you use positives or negatives, they're all going to work. So really, checking it with that one tells me that all 4 of them are going to work, because once you square it, it becomes positive and it becomes the same number as if you had a negative to start with. All right, so again, I don't need the extra space, but I put it in there because I wasn't sure how much space I was going to need. All right, so what about this one? X squared minus, or x to the fourth rather, minus x squared is equal to y, and x squared plus y is equal to 0. All right, so what do I want to do? Well, if I look at this one is already solved for y, so what I could do is plug that in here for y and then simplify. So if I do that, I have x squared, and then it's going to be plus this whole thing, plus x to the fourth minus x squared, and that's all equal to 0. Well, notice x squared minus x squared, that cancels, and I get x to the fourth equals 0. Well, if we take the fourth root of both sides, what do I get? Well, I get x is equal to 0. Okay, so that one, pretty nice, not too hard as far as figuring that one out, because 0 to the 1/4 is still 0. And now if I plug it in, what do I get? Well, if I plug in 0 here for x and 0 here for x, I get 0 for y. And so I get the simple 0, 0. And that's the only solution to this one. And again, if you think about it, we get 0 minus 0 equals 0, and 0 plus 0 equals 0. So our checks even show that it works in both equations. So that one really truly is the solution there. All right, so that's into part 2. I'll be back with part 3.